Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another lecture from the Stribus A to Z DSA course. Just in case you're for the first time here, this is world's most in-depth course when we talk about DS Algo. Why do I say that? Because this course has 455 modules. By the end of the course, you would have solved more than 400 plus problems on it. When it comes to DS Algo, you can go over the entire internet. You can buy any of the paid courses. None of them will be teaching you DS Algo in such depth. Something that I can give you as assurance is, once you complete this entire course, you'll be able to clear any of the DS Algo rounds in any of the companies in any part of the world. So till now we have covered up till this particular problem, and this video I'll be covering up the problem 3 sum. So what does the problem actually state? It states that you'll be given an array of integers and your task is to find out all the triplets that sum up to give you a value of 0. So basically in a triplet there are 3 elements. So if you sum up those 3 elements, the summation should be 0, and there is a critical point over here. You cannot take same elements more than once. What does it mean? It means, see over here, I've taken -1, I've taken 2, and I've taken -1. So there are 3 different elements, and over here I've taken 0, I've taken 1, I've taken -1. Again 3 different elements. What I cannot take is, I cannot take 2 twice. Even if this on summation is giving me 0, but I cannot take it because 2 has been taken twice and -4 has been taken once. I can take an element only once. That is the meaning of I not equal to j and j not equal to k. Now you have to return me all the triplets that sum up to give you 0. So in what order will you return all the triplets? The order can be anything, but the critical thing over here is you should not return duplicate triplets. What do you mean by duplicate triplets? Now you have a -1, 2, -1. Can I write this as -1, -1, 2? I can, and that will also give me the summation as 0. But this is something similar to this. So it's a duplicate triplet. You only have to return unique triplets. If I have to give you an example, let me just add a 2 over here. What if I add a 2 over here? I can say this triplet is generated by taking -1, this 2, and this -1. And I can take another triplet which is like -1, 2, and -1. And I can say -1 is taken. This time this 2 is taken. This 2. And then -1. Does it make it a different triplet? No. So you have to return all the unique triplets. So the best way is, if you just sort them up, you'll get -1, -1, and 2. So you cannot take any other triplet which is similar to -1, -1, and 2. You just have to return down all the unique triplets, and they cannot be repetitive, and it can be in any order. That is the question. So if this question comes up in the interview, what is the first solution that you'll give to the interviewer? That is definitely the brute force solution. And what is the most extreme naive solution that comes to your brain? It's like, why not try out all the triplets? And the triplets that gives us the sum 0, that is what we will return. And probably we'll just return the unique ones. So how do I try out all the triplets? So the triplets have 3 positions in them that you have to fill. Like the first element, the second element, and the third element. So if I have to ask you, can I say this is my first element? And then if I ask you, what can be my second element? You'll be like, this can be my second, 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 right? So for an example, let's say this is my first element and this is my second element. So which element can be my third? This can be my third, this can be my third, this can be my third, this can be my third. In this way, I've tried out all the triplets where this is the first and this is the second. Now what if I say, let's keep this as the first and this is the second, and probably this will be my third, or probably this will be my third, or probably this will be my third. Yes. Or I can say I'll keep this as first, this as second, probably this will be my third, or probably this will be my third. Or I can say I'll keep this as first, this as second, and this will definitely be my third. And then I can say that this might be my first, and this might be my second, this can be third, this can be third, this can be third. Or I can say this will be my first, this will be my second, this will be my third, this will be my third. Or I can say this will be my first, this will be my second, and this will be my third. So I can do it in this particular way. So can I say the first, so there are 3 elements, first, second, third. So can I for sure say the first can be this, or this, or this, or this, or so on till then? So I know one thing for sure. The for loop starts from 0 and it will go on till, let's run it till n. and it will take care of itself. Perfect. So whenever I is at 0, which means this is considered as my first. Which element will be my second? This one, or this one, or this one, or this, or this. So we know something for sure. If I is here, the second will start after that. There's no point in going back after that. Make sense? When I will be 1, which is this, where will the second element be? This, or this, or this. So I know something for sure. The second element will start from I plus 1 and it will go to that. Very sure. What about J? So 2 elements are done. What about the third? The third can be this, 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 this. And if I is this, J is this, which is the first and second. The third can be this, this, this. Do you observe? The third always starts after J. So, very simple. You say K equal to J plus 1 till N. And what you say is, hey listen, if array of I plus array of J plus array of K gives me something as 0, this is definitely my triplet. Simple as that. How do you store unique? That's a very easy job. I'll show you in the code. But can I say these 3 loops will make sure that I generate all the triplets. And the triplets will be array of I, array of J, and array of K. Now the task is to make sure that we do not have any duplicate triplets. How can we do that? So we did see something like that. Something like if there's a -1, probably a 2, and probably a -1. So in order to make sure we do not store any duplicates, what we can do is we can sort them out. And on sorting, we will have -1, -1, and 2. So once we have sorted them, if I get any other triplet, which is something like -1, -1, 2, I can actually compare. Or even if I get like 2, -1, -1, I can sort them. And after sorting, they will always be equivalent to this one, which I have taken. So what I'll do is I'll sort this particular triplet. And I know if I have to store unique, the data structure that we will use is set. I put that thing into the set. And anytime a triplet comes, I'll always check, are you in the set? If you are, no, I'll not. So this is how we can easily store all the unique triplets. I'll show you the code now. So let's quickly go into the code editor and show you the brute force code. So we know that we have to run 3 loops and all the triplets that give you the sum as 0, that is what you have to store. And the answer that we have to return should be a list of lists. So I'll probably store something like this. Okay. Now what I'll do is I have to store unique. Now probably I will store all the triplets in a form of vector, in a form of list. So this is what I've done. So I'll store everything in form of list. So what I've done is if the triplet is -1, -1, 2, I will store them in a set data structure in a sorted fashion. So probably I'll do something like vector int temp equal to num of I, num of j, and num of k. And then I can just sort this particular thing. Sort temp. So I'll sort this particular list. And once it is sorted, I can say, cool, I know whatever is this, like in whatever format is this, this will always be in -1, -1, 2. Now I'll say set, can you please store it? And it will always store all the unique ones. So these 3 lines will make sure that every time the unique things are stored. And then at the end, I can say, probably instead of declaring this here, I'll just pick up this and I can say answer, can you store in yourself everything from the set starting point to the set's ending point. So since this is list of list and the set is just containing the list, all the list from the starting to the end will go to this answer. Then we can easily return this answer. So this is how easily you can write the brute force code. So if you try to submit this brute force code, you will get a time limit exceeded. Why? Because the time complexity is somewhere near about big O of n cube, because you're running 3 loops, a logarithmic of number of unique triplets, because we're using a set data structure in order to store all the unique ones. Will I consider this sorting? We should not, because it is hardly 3 elements and the time will be as good as constant. So log, if the set is taking logarithmic, you can use unordered set as well. What about the space complexity? We are using a set in order to store all the triplets. And we're using an answer array to store all the triplets, right? So it's like 2 into bgo of number of triplets. Again, number of triplets is something which will vary on inputs, and this is what you have to tell to the interviewer. Got it? So with the brute force, we are using something like an n cube, and we are also using an extra space of the set data structure for which the interviewer will not be happy. This is where we will try to optimize the brute to a better solution. So n cube has to be optimized. And what can we optimize n cube to? We can probably optimize that to n square. And if you remember, we were having 3 loops for I, j and k. And that is why the complexity was n cube. So if I have to do it somewhere near about n square, how can we do that? We have to get rid of this third loop, and that is where the thought process starts for the better solution. So what I'll try to do is I'll try to get rid of this particular third loop. Can I write this statement as the third element that I'm looking for is definitely array of k, and that's equivalent to minus of array of I plus array of j. Can I see this? Simple mathematics. If I take this to the other side, it will be minus of this. If I take the minus common, because this is plus, so both of them will be minus, and I take the minus common. So what I'm looking for is, if I can run a loop for I and j, let me give you an example. So if I is this as of now, which is minus 1, and imagine if you're taking this minus 1. So that's minus 1 for array of j. So I know the third element that I'm looking for is minus of array of I, which is minus 1, and array of j, which is minus 1. So that gives me minus of minus 2, that's plus 2. So I'm actually looking for plus 2. If I'm standing here, I'm looking for, is there a plus 2 in the array? And I know there is one. So I say, yes, we can form a triplet. But in order to look for this plus 2 in the array, what technique? Yes, the better solution will be using the technique hashing. So the best way to look up for this plus 2 in this array without traversing is definitely hashing, because it does it in logarithmic or constant time. So this is why the better solution will be using hashing. Now let's quickly do a dry run of the hashing solution that I am talking about. So while writing the algorithm or code for this one, we have to be critical about one thing. All the 3 elements are different. So while implementing hashing, we cannot just implement the entire array into a set or a map data structure. Why? Imagine you have taken this 2 as array of I, and you've taken this minus 4 as array of j. So apparently, if you remember the formula, it was minus of array of I plus array of j. So what you look for is this. You look for plus 2 in the array, and you'll get that plus 2 over here, which is wrong, because you cannot pick up one element twice. So you have to be mindful that if you're looking for plus 2 in the array, then we have to be sure that it is not the current 2 and current minus 4 that you have taken for array of I and array of j. It has to be someone different from that. That has to be kept in mind. How can we do that? That is very simple. Imagine you are at minus 1. So what you will do is, you'll just keep these elements in the hash map. Yes, you'll just keep these elements in the hash map. And you'll say minus 1, okay. You'll say minus 1, okay. And then a minus of it. So minus of this minus 2 is plus 2. Now you look for plus 2 and you'll find it. So you will avoid duplication. How to do this? Let me show you a dry run. So what I'll do is, at first I'll take a hash set, okay. And I'll start my I and j loop. First I will be here and j will be here. Okay. This time the hash set is empty. But I'll take, if you remember the formula, for the third element, it's array of I plus array of j. This is what the third element was, if you remember. So I'm looking for the third element. So what is array of I? Minus 1 plus 0 minus. So this is minus 1 and this is plus 1. Is plus 1 in the set? No. So what you'll do is, you'll go ahead and you'll move this j. But before moving, just take this 0 and put it into your hash map. Done. This time when you try, you'll get minus 1 plus 1 and a minus of it. So minus 1 plus 1 is 0. So you'll get 0. And in the hash set, there is a 0. So apparently I got a triplet as minus 1, 1 and 0 from the hash set. I can sort it and then I can store it again. Something like minus 1, 0 and 1. So this is one of my answers. Perfect. Next, I'll move, but before that, please put on 1 and then move. Let's move. So if you carefully see, what I'm doing is, I'm standing at here. Everything on this thing is in the set. This time I have a -1 and a 2. So I'll say, okay, let's take -1, let's take +2, which makes it how much? That's +1 and a -2, it will be -1. Is -1 in the set? No. So I'll move, but before that, please put up 2 and then you can move. Let's move. This time again, let's carefully observe. You have a -1 and you have a -1. So how much does this give? -2 and a minus outside, +2. Is there a -2? There is. There is. So one more created. Again, carefully observe. All the 3 elements are in the set. So what you'll do is, you will say there is one more and you can again write it in a sorting order in a set. Perfect. Now, next, I'll put this -1 in the set and I'll move the j. This time when I move the j, I'm at -4. So -1 and -4 is -5, or minus of that is +5. Is the +5? No. So once the j reaches over here, can I say one thing for sure? All the triplets with -1 as I are done. Because I've tried out all the second elements, I've got kind of the third element. So done. So this time, I can say the journey is over, but probably this element can be my first, maybe. Therefore will be my second. This, maybe. So, but if I keep everything in the hash set, it will be wrong. So what I'll do is I'll omit everything. And I'll start the j from here. Again, the set is empty. So we'll again start with 0, 1, 0 plus 1. And we'll again find no 1. And then we move. But before moving, take this one and this time have this. This time what you get is 0 plus 2, which is -2. And that's not in the set. Just put up 2 and move. And when you move, you will be here, which is nothing but -1. So this time carefully see, you are at 0, you are at -1 and you have a minus. So what you get is +1. And +1 is in the set, but that will be a triplet of 1, 0. Sorry, by the way, I'm mistaken. It's 0 for this. It's -1 for the second. The third one comes from here, which is 1. So basically this one, and this one have been written. But if you sort them up, you'll get -1, 0, 1, which is already there. So the set will make sure you only store the unique ones. The answer set will make sure. Alright? And similarly, you can move ahead. And in the next step, I will move here. In the next step, I will move here. And you can keep on doing this till I doesn't reaches the end. And this is how easily you can do this. So this is how the algorithm will be. I will use just 2 loops for I and j, and for the third element, which is this, I'll try to find it in the set data structure, and I'll show you the code. Let's quickly jump into the code editor, and as you can see, I've written some pre-code. So initially, I'll declare a set of list because we have to store all the triplets and we have to make sure that those all are unique. And then we know we have to run a loop for the first and then for the second. And at the end, all those lists will be converted and put into a list of lists, and that is what we will return. So running 2 loops. So if you remember something, initially I was over here and j was over here, and this set did not have anything, right? And then when j moved here, it just picked up this and stored. And then eventually when j moved here, it picked up this and stored, and it kept on storing. And after that, when I moved here, the set was again empty. So I know one thing, whenever I change the first position, the set has to start from an empty one. That is why I'm declaring it after the for loop. So every time it reinitializes whenever I is incremented. And every time j moves, I have to accumulate, I have to accumulate that element into my set. Perfect. This is something I know for sure. Now I know one thing for sure. What is the third element? The third element is nothing but minus of num of I plus num of j. Correct? I have to find that in this particular hash set. I and j in between them. Yes. So what I'll do is, if hash set dot find third is not equal to, because if it is not pointing to the end, it means it is there in the set. If it is, can I say this is a triplet? And what is the triplet? Triplet is num of I, num of j, and third. I can definitely say that. And then I just need to sort it. So let's quickly sort it. Once I've sorted it, what's the next thing? Let's put that into the answer of set. and that will make sure it stores unique, and then I can easily return it. So probably this is a spelling typo, and if everything is fine, let's quickly run it off and see if it is running fine. So you'll see that this is getting accepted, and a lot of compilers, it might give you TLE, but I will just analyze the time complexity. It is somewhere about n square because of these couple of loops, because n and n, and not exactly n square, somewhere about n square. And we're using a set data structure to find every time. So it is kind of similar to n square login. Can I see this? So the time complexity will be n square near about, and logarithmic of size of the set. Initially the size of the set can be just 1, and then it becomes 2, then it has 3 elements, then it has 4. So this log, I write it as m. It's not exactly n, it is m, which is variable. For the first time it just has 0, then it will have 1. So the size of the set is varying. Again, this logarithmic can be treated as constant if you're using something like an unordered set. So I can say near about n square. Yes, what about the space complexity? I'm using this particular hash set every time. For the first time, it might end up storing 1, 2, 3, 4 or 5 elements. Next time it will store 1, 2, 3, 4. Next time it will store 1, 2, 3. But at the max, it will store 1, 2, 3, 4, 5 when I is here and j is here. At the max, it will store all the elements, which is near about all the elements of the array. So I can say we are using a bgo of n, and we are repeatedly using the same hash set. And also we are using a set to store all the answers, which is again number of unique triplets into 2. Why? Because we are also using a list of list, which returns all the answer. So twice of this, because we are using still our external data structure in order to get all the unique triplets. This external data structure is what the interviewer might not like. Might be okay with the time complexity because n square is somewhere what he might have expected, so you've got it nearly, but he might still now ask you to get rid of this external data structure, and this is where the optimal solution comes in. So in both the brute and better solution, we were using something like a set data structure, which was helping us to get all the unique triplets because it was filtering out all the duplicates. And how are we doing it? Basically, if the triplet generated was something like 0, -1, 1, we were trying to sort it, and that gave us -1, 0, and 1. And then we were putting that into a set data structure. Now we have to get rid of this set data structure. So we will try to do the reverse. We will sorting the triplet and then storing it into the set. What I will try to do is, I will this time try to sort this particular array. Yes, I'll try to sort this particular array. And then I'll try to formulate an algorithm so that I just get all the unique triplets and I do not require an external data structure to filter out the duplicates. So sorting of the array is something that I'll do at first. In order to explain you the algorithm, I've taken a bigger example, and this is a sorted array. Why do we require a sorted array? As I tell you about the algorithm, you'll understand it. So the algorithm will be a 2-pointer approach, a very, very straightforward 2-pointer approach. So what am I looking for? I'm looking for array of I plus array of j plus array of k. Okay, this is what I'm looking for. This time what I'll do is, I'll say, hey, listen, I'll probably fix the I. So what I do is, I fix the I over here, okay? And now I'm looking for j and I'm looking for k. What I know for sure is, this is entirely in a sorted order. This is entirely in a sorted order. So I'll probably keep the j here and I'll probably keep the k here, okay? This is what I'll do. Initially, I will be fixed here and j will be kept at 1 after I, and k will be kept always at the end. Perfect. Now what I'll try to do is add up these 3 elements. Let's try to add it up. -2, -2, and 2. So if I add it up, what will I get? I'll get a -2. And what was I looking for? If you remember, I was looking for 0. So I'm getting a value which is lesser than 0. So if something is lesser than 0, what do I need to do? Remember, I will always be constant. I will not move. What do I need to do? In order to get near to 0, I have to increase the value. I have to kind of increase someone's value. And if this is constant and these two can move, how can I increase the value? If I go this way, since the array is sorted, hear me out properly. Since the array is sorted, the values will decrease. The values will decrease and the -2 will go down. I need to increase -2. I need to increase the value of -2. So what I will do is, I will move this element, yes, I'll move here. And even if I move here, it is still -2. I'm like, I still need to increase it more. I'm like, okay, you need to increase it more. Let's go to -1. This time when you try to add -1, what happens? Let me show you. Just a second. Yeah. If I try to add -1, this time this -2 will become -1. Slightly increased. I'm still not near 0. So I'll say, let's move a bit further. So I move a bit further. It still stays the same. I move a bit further. Still stays the same. I move a bit further. This time when I have a 0, I get a 0. -2, 0 plus 2. I am getting a 0. So what I did was, I just kept on moving and I tried to reach near 0. And apparently at this moment, I have one I have one I have one J, and I have one K. And that is one of my triplets. I'll probably store it. And I know the triplet is very simple. It's -2, 0, 2. It's already in the sorted order. If you carefully see, it's already in the sorted order because you took a sorted array. You had I at the left. You had J in the middle. You had K at the right. So it is already in the sorted order. Got it? Next, you are at 0. What can you do? You know, this cannot be taken. This cannot be taken any further. So what you will do is, you will simply move both of them. And the moment you move both of them, it will come over here. And this time, this K will come over here. A careful thing. If you just move it by one place, what will happen is, you will again end up taking -2, 0, and +2. You need to avoid this because we need to make sure we just store the unique triplets. We avoid duplicates. So what you will say is, I moved it one place, but I should not move it one place. I should actually move it more. I should just move it out of 0. I'll not take 0. No further 0. I'll not take 0. I'll move it out. I'll be like, okay, let's move. What is the place where there is no 0? That's this place. Perfect. I'll move it. And for K, I'll be like, I was here now. That was 2. I'll no more take 2. I'll no more take 2. Move it. So I will move it. And if I try to move it, what will happen? Where will K? K will be here. And the moment J and K cross, what happened? You firstly assumed I to be your left, J to be your mid, and K to be your right. So that they always are in sorted order. If K has moved, it's no more in the sorted order. So you stop. Yes, you stop. Perfect. Stop. Next. This I, which is constant, will try to move. Again, there's a catch. If this is -2, you again don't take -2 because you'll again generate the same triplets. So you move to the element which was not -2. So the moment you try to move to the next, you'll be like, hey, wait. You were equivalent to the previous. No, go ahead. I've already done. I move here. And he's like, hey, you were equivalent to the previous. No, go ahead. And then I stop at -1, which is not equivalent to my previous. So I stop at -1. So this is my, as of now, I. Perfect. I this time start at J, which is here. And K will again be here. Amazing. So -1, and +2. This is where I start. So I got a -1, I got a -1, and I got a +2. So what I'm saying is, aren't they giving me 0? They are. They are giving me 0. So this is one more triplet, -1, -1, 2. So I take this triplet. And logically, I should have moved this by 1 place. Because I cannot take these guys anymore. And I should have moved the K by 1 place. Logically, I should have done this. But, I know one thing. I cannot take any further -1. So I'll be like, oh, you are still equivalent. Move. And it'll stop here. And I'll say, still 2. Move. It stays here. Perfect. Now, what happens? Where are we? -1, 0, 0. What's the value? -1. It's lesser than 0. What do I need to do? I need to increase. So I'll try to increase. I'll try to increase. Still the same, so I'll still try to increase. And the moment I reach same elements, stop. Done and dusted. Next, I'm at -1. That was the I was constant, so I'll try to move it. The moment I try to move it, it says, hey, you are still equivalent to the previous. Still equivalent to the previous. I've already done for you. Move, move, move. I'm like, hey, you're still equivalent. Move. Oh, you're not equivalent. Oh, we can probably do. So this time, I start J here, I have K here. Again, very critical to observe. 0 plus 0 plus 2. What's the value? 2. Greater than 0. Reduce, reduce. Greater than 0. Because it's greater than 0. Reduce. So you'll move this, because if you move left, the values will reduce. 2 pointers usually work like this. Still greater than 0, and you reach here. So you get another triplet. Very, very careful. Sorry, very, very important. You get another triplet. Will you consider this? You will. Because the 3 zeros are from different. So you will take another triplet. Perfect. Next. You know this 0 is there, so you'll move K. After this K moves, J moves. So it's over. So in this way, you can keep on doing. And eventually, you'll get all your triplets. When I moves, when it moves here, same as previous, so I will again start from here. So eventually, you will keep on doing. And you will ultimately get just 3 triplets for this one. Got it? So I'll get back to the code editor and try to code it. Please make sure that you try out the problem from the link in the description itself. That will help me a lot. So what I'll do is, I know that I have to return a list as the answer. So this is what I'll initially do. And I know one thing for sure, I will always be constant. So probably, yeah. So something I know for sure is, if it's equivalent to the previous. If you remember, whenever I was, imagine standing here. It is equivalent to the previous, so you'll not do. This was also equivalent to the previous, you'll not do. Only for the first element, there is no previous. So I'm like, one thing for sure, if it is not the first element, and num of I is not equal to num of, or you can say equal to num of I minus 1. That means it's equivalent. So you'll say, please go ahead and continue. Continue means it will not go down. It will just go here and do the next step. And if it is not, then I go down and do all the steps. Continue clearly states, do not go down. Go back to your for loop, increase I and do the next step. So I know if it is equivalent, I'll not do. If it is not, then I'll do. And I'll probably say J is equivalent to I plus 1. And I'll say K is equivalent to the last element, which is N minus 1. Done. I know one thing. I'll keep moving the J. If you remember, J was here, K was here. And we kept on moving till they did not cross. That is what I'll do. While J, this will just keep them moving. And I know there will be 3 conditions. What will be the 3 conditions? We'll have to add them up. So it will be like num of I, or maybe since I'm going to use this everywhere, sum num of I plus num of J plus what is the third element, num of K. I know one thing. If sum is lesser than 0 is 1. Else if sum is greater than 0 is other, and the else is less. So I know if it is lesser than 0, I need to increase. In order to increase, it's a sorted element. It's a sorted array. So please make sure you sort the entire array. Otherwise, it will be an issue. So please go ahead and sort the entire array. Perfect. And now I need to move this J so that it increases. If it is greater, I need to decrease, so K minus minus. If not, that means it's equal. This is one of my triplet for sure. So what now I will do is, I'll take vector of n. This is one of my triplet for sure. And I'll put them in. Amazing. Number of J and number of K. And once I put them up, I know they will directly go into this answer. Do I need to sort them? Think on that. No, it's already in the sorted order. So I'll just go and say push back temp. Amazing. Now, what is the next job I have to do? I know J and K cannot be seen. So I'll just move them one ahead. And I'll also move this one back. So if you remember well enough, we had a -2 as the I, we had this one as the j, and we had this one as the k. And after that, what we did was we moved j by 1 step and we moved k by 1 step. But if we do this, what will happen is in the next step, this 0 and this 2 will again form another triplet, which is wrong. I don't want that. So what I'll do is I'll move it by 1 step. Then I'll check. Is it equivalent to the previous? It is. So move it by 1 step. Is it still equivalent to the previous? Yes, move it by 1 more step. Keep moving till it is equivalent to the previous. Because it matched. So I'll keep it moving till num of j is equivalent to its previous. Keep moving. And at the same time, I'll say, hey, listen, num of what? K is equivalent to its. So over here, k is at this, and it's still equivalent to this, so I'll move it. And it's still equivalent to this, so I'll move it. And it's still equivalent to this, so I'll move it. So one ahead. It's like num of k plus 1 and k minus minus. Do we just keep on doing this because it might run out of boundary. So this is why just make sure there is a simple case which states just keep on doing till it doesn't crosses the k, because if it crosses, we're done and dusted. There's no need to do it. As long as it is something like this, keep on doing. And if it somehow crosses, we know we've crossed. There's no point in doing more. And this is how the while loop will look like. And now we can go ahead and run this and see if it is running fine. So what about the time complexity? N log n to sort it. So I can say an n logarithmic of n to sort the array. And then we are running an external n loop. So that's a bgo of n and then the while loop. How many times will the while loop run at first? N minus 1 time. Next, n minus 2 time. Next, n minus 3. So it's kind of running every time for n, near about n. So n into n, near about. So n log n plus near about n square will be my time complexity. What about the space complexity? We're not using anything to solve the array. We're just using a big of 3 space. But yes, we are using a answer list in order to return the answer. So that is for returning, not in our algorithm. So big of number of unique triplets. We will not be counting this temp because it's just 3 elements. So this is the time complexity and space complexity for the most optimal solution. Now I'll go back to the sheet and I'll mark this as done and completed. I hope I've understood all the 3 approaches, all the 3 codes. Just in case you did, please do give us a like because it won't cost you anything. But that will do me a world of good. And if you haven't followed me on Instagram, you're missing out on a lot of informative content. So Strive_79 is what I go by on Instagram. Please do follow me over there. And if you're new to our channel, what are you waiting for? Hit that subscribe button. And yes, with this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken.